Assalamu alaikum students. This video is for matrix algebra part 3. So before this lecture I have already given two video lectures on matrix algebra. So today we will study application of matrix algebra in business. Application of matrix algebra in business or in production sector. Right. Suppose the first question that we will solve here is, suppose a company makes liquid products in three grades. A company makes liquid products in three grades: low grade, mid grade and high grade. Suppose a company makes liquid products in three grades, so low grade, mid grade and high grade, which contain different amounts of additives. So which contain different amounts of additives. So additives means it's a kind of chemical. So which contain different amount of additives A1, A2 and A3 per gallon as shown in the following table. So which contain different amounts of additives A1, A2 and A3 per gallon as shown in the following table. Right. So low grade liquid. So low grade liquid, if you make x 1 gallon, if you produce x 1 gallon of low grade chemical, if you produce x 1 gallon of low grade liquid, in x 1 gallon of low grade liquid, pounds of additive per gallon in every 1 gallon excuse me, in each gallon of low grade chemical, in each gallon of low grade liquid, 1 gallon of A1 is there, 1 gallon of A2 additive is there, 1 gallon of A3 additive is there. I'm repeating again. In each gallon, pounds of additive per gallon. So that means in each, now we are discussing about the low grade liquid. In each gallon of low grade liquid, 1 gallon of A1 type of additive is there, 1 gallon of A2 type of additive is there, and 1 gallon of A3 type of additive is there. Right. So in mid grade liquid, in every gallon 1 pound of A1 additive is there, 2 pounds of A2 additive is there, 1 pound of A3 additive is there. So if we produce high grade liquid, in every gallon of high grade liquid, 2 pounds of A1 additive is there, A2 additive is not there. A2 additive is not there in high grade liquid. That means 0 pound of additive. That means no A2 additive is there in high grade liquid. 1 pound of A3 additive is there in every gallon of high grade liquid. Now we need to find out how many gallons of low grade, how many gallons of mid grade and how many gallons of high grade liquid we need to produce with the available resource. Available resource means we have total 20 gallons of A1 additive is there. We have total 20 pounds of A1 additive is there, 30 pounds of A2 additive is there, and 20 pounds of A3 additive is there. So with this available resource, we need to find out how many gallons of low grade liquid, how many gallons of mid grade liquid and how many gallons of high grade liquid we can produce. So I'm repeating the question again. Right. So a company is producing three types of liquid: low grade, mid grade and high grade. So right. So in each gallon of low grade liquid, 1 pound of A1 additive is there, 1 pound of A2 additive is there, 1 pound of A3 additive is there. in every gallon of mid-grade liquid, 1 pound of A1 additive, 2 pounds of A2 additive, and 1 pound of A3 additive is there. In every gallon of high-grade liquid, 2 pounds of A1 additive and 1 pound of A3 additive is there, but A2 additive is not there in high-grade liquid. So the company have total 20 gallons of A1 liquid in their hand, 30. So company have total 20 pounds of A1 additive, 30 pounds of A2 additive, and 20 pounds of A3 additive in their hand. So now we need to find out how many gallon of low grade liquid we need to produce, how many gallon of mid grade liquid we need to produce, how many gallon of high grade liquid we need to produce with the available resource. Available resource means we have these 20 pounds of A1, 30 pounds of A2, and 20 pounds of A3 available. So with the available resource, how many gallons of low grade, how many gallons of mid grade, and how many gallons of high grade liquid we can produce. Let us assume that we will produce x1 gallon of low grade liquid, x2 gallons of mid grade liquid, and and x3 gallons of high grade liquid. So let us assume that we will produce x1 gallons of low grade liquid, x2 gallons of mid grade liquid, and x3 gallons of high grade liquid. So you can assume it as xyz also, right? So you can assume it like anything, right? So these are the three variables we need to find out. So we need to find out the values of three variables, right? So we need to find out how many gallons of low grade liquid, how many gallons of mid grade liquid, how many gallons of high grade liquid we need to produce, right? So we need to develop some equations. How we develop equation, right? In every gallon of low grade liquid, 1 pound of in every gallon, so she is saying pound of additive per gallon. In every gallon of low grade liquid, 1 pound of A1 additive is there. So if you produce 1 gallon of low grade excuse me, if we produce 1 gallon of low grade liquid, we have 1 pound of A1 there. But we are producing x1 gallon of low grade liquid. We are producing x1 gallon of low grade liquid. If we produce 1 gallon, then if we produce 1 gallon of low grade liquid, then 1 pound of A1 is there. If we produce 2 gallon of low grade liquid, then 2 pounds of A1 is there. If we produce 3 gallons of low grade liquid, then 3 pounds of A1 is there. But we are producing x1 gallon of low grade liquid. So in x1 gallon of low grade liquid, we will have x1 multiplied by 1, that is x1 pound of low grade liquid. So x1 pound of low grade liquid is there. So x1 pound of additive is used in low grade liquid. I am repeating again. If we produce 1 gallon of low grade liquid, we will use 1 pound of A1. If we produce 2 gallons of low grade liquid, we will use 2 pounds of A1. If we produce 3 gallon of low grade liquid, we will use 3 pounds of A1. But we are producing x1 gallon of low grade liquid, so we will be using x1 multiplied by 1, that is x1 pounds of A1 additive for low grade. So x1 pounds of A1 additive has already been used, right? So now here again, now let's move to mid grade, right? So if we produce 1 gallon of mid grade liquid, we use 1 pound of A1. If we produce 1 gallon of mid grade liquid, we use 1 pound of A1. If we produce 2 gallon of mid grade liquid, we will use 2 pounds of A1. But we are producing x2 gallons of mid grade liquid, so we will use x2 pounds of A1. So So that means we are using x2 pounds of A1. Right. So just a minute, let me write here A1 so that you get a clear understanding. So this is the equation for A1, this is the equation for A2, this is the equation for A3. Right, I'm repeating again. So we are producing, if you produce 1 gallon of mid-grade liquid, we will use 1 pound of A1. If we produce x2 gallons of mid-grade liquid, we will use x2 pounds of A1. So x2 pounds of A1 is using. So here we are using x1 pounds of A1 to produce low-grade liquid. Here we are using x1 pounds of A1 to produce so here we are using x1 pounds of A1 to produce x1 gallon of low grade liquid. Here again we are using x2 pounds of A1 to produce x2 gallons of x2 gallons of mid grade liquid. So that means x1 pounds plus x2 pounds of A1 has been used already. So again we are producing here, if we produce 1 gallon of high grade liquid, we will use 2 pounds of A1. If we produce excuse me, if we produce 2 gallons of high grade liquid, we will use 2 multiplied by 2, that is 4 pounds of A1 liquid. If we produce x3 gallons of high grade liquid, we will use x3 multiplied by 2, that is 2x3 pounds of A1. So that means total uses is, that means we are using this x1 pounds of A1 liquid to produce low grade liquid. We are using x2 pounds of A1 liquid to produce mid grade liquid. We are producing 2x3 pounds of A1 liquid to produce high grade liquid. So that means total A1 liquid we have in our hand is 20. Total A1 liquid we have is 20 pound. So we have total 20 pounds of A1 liquid in our hand. Now let's move to next one. Here A2. So that means A2, that means here if we produce 1 gallon of low grade liquid, we will use 1 pound of A2. So if we produce 1 gallon of low grade liquid, we will use 1 pound of A2. So we are producing x1 gallon. So to produce x1 gallon, we will use x1 pound of A2. So we will use x1 pound of A2. So this much has been used already, right? If we produce 1 gallon of mid grade liquid, we will use 2 pounds of A2. We are producing x2 gallons of mid grade. So to produce 1 gallon, we will use 2 pounds of A2. If we produce x2 gallons, we will use 2 multiplied by x2, that means 2x2 pounds of A2. So 2x2 pounds of A2, that means we are also using 2x2 pounds of A2, right? Here to produce 1 gallon of high grade liquid, we are not using any A2 liquid. So 0 A2 liquid. So 0 A2 liquid. So that means 0 A2 liquid, 0 A2 liquid. So 0x3. So that means total A2 liquid we have is 30 pound. We have total 30 pounds of A2 liquid in our hand. Now let's move to the next one. If we produce 1 gallon of low grade liquid, we will use 1 pound of A3. So that means here we are producing x1 gallon of low grade liquid. Excuse me. To produce 1 gallon of low grade liquid, we will use 1 pound of A3 liquid. To produce 1 gallon of low grade liquid, we will use 1 pound of A3 liquid. We are producing x1 gallon of low grade liquid, so we will use x1 gallon of A3 liquid. So we will use x1 gallon of A3 liquid, x2 gallon of A3 liquid, and x3 gallon of A3 liquid. So that means total uses of A3 liquid will be x1 plus x2 plus x3, and total available is 20 pounds. Total available is 20 pounds. So now this is the three equation we have. Here we have three equation. So here we have three equation. This one can be called equation 1, this one equation 2, this one equation 3. So we have total three variables, x1, x2 and x3. Three variable. You can name it, we could name it as like x, y and z instead of x1, x2 and x3. There's no problem with that. So we need to solve this three set of equation. So we need to solve this set of equation. So we need to solve this set of equation and find the value of x1, x2 and x3. So we can solve this using Cramer rule. So in my previous video lecture, I showed you how to use Cramer rule to solve a set of equation. Now today I will show you how to use inverse matrix method. I will show you how to solve this set of equation using inverse matrix method. So here, so let us remove these one. So that means these are the three equation we have. So this is the equation we have. This is the another, sorry. This is the second equation we have, and this is the third equation we have. Right, this is the third equation we have. So now we will solve this. You can easily solve this set of equation using Cramer rule. Using Cramer's rule, you can easily solve it. In my previous video lecture, in the matrix algebra part 2 video lecture, I showed you how to solve a set of equation using Cramer's rule. So today I am going to show you how to solve a set of equation, and find the values of the variable using inverse matrix method. So to solve this set of equation, using inverse matrix method, first of all we need to get coefficient matrix. So first of all we need to get coefficient matrix. So here, so coefficient of x1, so this is coefficient in the first equation. What we have here, the coefficient of this variable is what? Coefficient of this variable is 1. Again, coefficient of this variable is what? 1. Coefficient of this variable is what? 2. Coefficient of this variable is 2. Sorry, coefficient of this variable is 2. Now this one, second equation, coefficient of this variable is what? 1. Coefficient of this variable is what? 2. Coefficient of this variable is what? 0. So here coefficient of this one is 1. Coefficient of this one is also 1. Coefficient of this one is also 1. So here we have taken the coefficient of these variables serially. The first we take x1, coefficient of x1. Second we take coefficient of x2. Third we take coefficient of x3. Right. So that's why we need to write here. We need to write these variables serially. So we will write it like this way: x1, x2 and x3. So we will write it serially. We will write it like serially. I am repeating again. So first of all, this is the first column represents coefficient of x1. So first column represents coefficient of x1, second column represents coefficient of x2, third column represents coefficient of x3. Since we have written the coefficient serially like x1, x2 and x3, that's why in the column we will write the variables serially also. And then we will write equal, and then we will write what we have in the right hand side equation. In the right hand side of the equation, we need to write whatever we have on the right hand side of the equation. So 20, 30 and 20. So this way we can convert a set of equation like in matrix notation. So this way we can convert a set of equation into matrix notation. Right. So here let us name this matrix. Let us name this matrix as A. Let us name this matrix as A, and let us name this matrix as X. So let us name this matrix as X is equal to, and let us name this matrix as B. So let us name this matrix as B. So let me give a side note here so that you don't get confused. So here A is equal to this matrix. So here A is equal to this matrix. So A is equal to this matrix. B is equal to, not B, let me write X now. So X is equal to this one. This is actually not matrix, we will call it a column vector. So as you know that if you have only one column, we will call it a column vector. So this is the column vector of X, and B is equal to this one. B is equal to this one. So B is equal to this one. So we have assumed it like that. So this one is A, this one is A, this one is X. So A multiplied by X is equal to B. So obviously we want to find out the values of this column vector. We want to find out the values of these variables. So that's why we will assume that means we want to find out the values of these variables. So that means we will find out the values of this column vector. So that means we want to find out the value of X. So X will be equal to what? So X will be equal to, if you move A to right hand side, what we will have? B divided by A. So B divided by A means if you move A from denominator to numerator, if you move it up, it will become A power minus 1. Multiplied by B. So that means this is actually inverse matrix. A power minus 1, that means inverse matrix of A. So this one indicates that we will get inverse matrix of A, right? We will get inverse matrix of A, and the B is the whatever we have. B is the column vector that represents whatever we have in the right hand side of the equation, right? So first of all we need to find out inverse of this matrix. First of all, we need to find out inverse of this matrix. So in the step 1, we need to find inverse of this matrix. So step 1. In the step 1, we need to find inverse of these matrix. That means we need to find this one. First of all, we need to find this one. So this one is equal to what? So we need to find inverse of these matrix. So that means we need to find inverse of this matrix. So first of all, we need to find inverse of these matrix. So I have already shown you how to find inverse of a matrix using cofactor matrix method and Gauss-Jordan method. So suppose here you will use cofactor inversion method and you will write the answer. So at this moment I am not going to show you how to get the inverse of a matrix. So at this moment I am not going to show you how to get inverse of a matrix. Okay, I have already calculated inverse of this matrix. I have already calculated inverse of this matrix. So inverse of the matrix, inverse of this matrix, that is the inverse of this matrix, that is a power minus 1. So inverse of the matrix is what we get, minus 2 minus 1 4 1 1 1 minus 2 1 0 minus 1. So this is the inverse matrix that we got. So minus 2 minus 1 4 1 1 minus 2 1 0 minus 1. So this is the inverse matrix that we got, right? So the x, so this one we know that x is equal to sorry, x is equal to, we know that x is equal to this one. So x is equal to this one, we already know that. So x means what? X means this one, x means this one. So x means this one. So this one will be equal to what? So this one will be equal to this one. So this one, x is this one. We know that x is the column vector of this one, and a power minus 1, that is the inverse matrix. So inverse matrix is this one. So inverse matrix is this one, and b is this one. B is this one. So b is this one. So we need to multiply these one to find out the values of this variable. That means to find out this column vector, that is the values of this variable. What we will do, we will multiply this matrix with this column vector. So we will multiply this, right? So let us multiply. So this is a 3 by 3 matrix. So dimension of this matrix is what? 3 by 3, and dimension of this one is, we have 3 rows are there. So we have 3 rows are there. So this is 3 by 1 matrix. So this is a column vector, but if we say it by as matrix, if we find out the dimension of this matrix, we will, dimension of this one is, we have 3 rows are there and only 1 column is there. So this is 3 by 1 matrix. So I'm repeating again. So dimension of this matrix is 3 by 3 matrix, and the dimension of this one is 3 by 1 matrix. So dimension of this one is 3 by 3 matrix, and the dimension of the, so dimension of these one is 3 by 3 matrix. So 3 by 3 matrix, and dimension of these one is, we have 3 rows are there and only one column is there. So dimension is 3 by 1 matrix. So we can see that we can do the multiplication, since this one is matching with this one. So we can do the multiplication. So if you do the multiplication, these will no longer be there. So the resulting matrix will have 3 rows and only 1 column. So the resulting matrix will have 3 rows and only 1 column. So let us get 3 rows and 1 column. Right. So let us multiply first. As we know that we will multiply first row with the first column. So we will multiply the first row with the first column. So first row of the first matrix and the first column of the second matrix. So let us multiply element by element. So minus 2 multiplied by 20 plus minus 1 multiplied by 30 plus 4 multiplied by 20. 4 multiplied by 20. So let me revise again. Minus 2 multiplied by 20, correct. Minus 1 multiplied by 30, correct. 4 multiplied by 20, correct. The next one, now we will move to the second row. So in the second row, what we have, 1 multiplied by 20 plus, so 1 multiplied by 20 plus 1 multiplied by 30, 1 multiplied by 30 plus minus 2 multiplied by 20. So minus 2 multiplied by 20. So let me revise again. 1 multiplied by 20, 1 multiplied by 30, and minus 2 multiplied by 20. Correct. Now let us move to third row. Let us multiply third row with the first column. Right. So what we will get, 1 multiplied by 20 plus 0 multiplied by 30 plus minus 1 multiplied by 20. Minus 1 multiplied by 20. So 1 multiplied by 20, 0 multiplied by 30, minus 1 multiplied by 20. So let us calculate. So if we calculate this one, what we will get? 4 multiplied by 20 is 80, minus 30 is 50, 50 minus 40, 50 minus 40, 50 minus 40 is 10. So we are getting 10. Let me revise again. 4 multiplied by 20, 80, minus 30, that is 50, 80 minus 30, 50, minus 40, 50 minus 40 is equal to 10, correct? So this one, what we will get here, 20 plus 30, that is 50, 50 minus 40, again 10. So here also 10. So what we are getting here, 20, and this is 0. So 20 minus 20, 0. So here this one is 0. This one is 0. Right. So that means what? So that means the values of this column vector, is these ones. The values of this column vector is this one. So the values of this column vector is this one. So that means what we can write? We can write x1, the value of x1 is equal to 10 serially. The value of x2, is also 10. The value of x3 is 0. So what it means actually? So that means we will produce 10 gallons of low grade liquid, 10 gallons of mid grade liquid, 0 gallons of high grade liquid. So that means the company need to produce 10 gallons of low grade liquid. So that means low grade liquid they need to produce is, that means low grade liquid they need to produce 10 gallons. This one is what? Mid grade liquid. So mid grade liquid they need to produce again 10 gallons, and this is high grade liquid. So high grade liquid they should not produce. High grade liquid they should not produce. 0 gallons means they should not produce high grade liquid. So this way you can solve in real life. In real life, if you work as a production manager, you will be working with, you need to work with limited resources. You will need to work with limited resources. So you need to decide, for example, this here you have only 3 kinds of product: low grade, mid grade and high grade liquid. But in real life you may have to deal with 50 different products, but and those 50 different products may use same resources or similar resources. So as a production manager, you need to design, you need to find out with those available resources which product, how many units or how much of which product you need to produce. So this way in real life you can use matrix, to find out the how many units or how much of each product you need to produce with the available resources. Now let us solve another question. Right, question number 22. 2 canned meat spreads, regular and superior, are made by grinding beef, pork and lamb together. So canned meat spread, that means like canned food. This is canned food that contains meat spread, that means as a grinded meat. So 2 canned meat spreads, one is regular and the other is superior, are made by grinding beef, pork and lamb together. The number of pounds of each meat in a 15 pound batch of each brand are as follows. So the number of pounds of each meat in a 15 pound batch of each brand as follows. So in every batch they produce 15 pound. In every batch they produce 15 pound. Right. So that means, so they have 2 brands of meat spread, superior and regular. So in superior brand they use 8 pound of beef, 2 pound of pork and 5 pound of lamb meat. So that means total 15 pound. And in regular brand they use 4 pound of beef, 8 pound of pork and 3 pounds of lamb. So another again 15 pounds. Suppose we wish to make 10 batches of superior and 20 batches of regular. Suppose we wish to make 10 batches of superior and 20 batches of regular. Multiply the meat matrix in the table and the batch vector and interpret the result. So question is asking us to, suppose here we wish to make 10 batches of superior and 20 batches of regular. So we want to produce 10 batches of superior and 20 batches of regular. And this is the meat matrix. Where, so this one represents superior and this one represents regular. Right. So question is asking us to multiply. This is the batch vector. this is the batch vector, and this is the meat matrix. This is the meat matrix. Question is asking us to multiply these two and interpret the result, So this is the batch vector. So here this one represents we want to produce 10 batches of superior. So we want to produce 10 batches of superior and 20 batches of regular. And in superior batch, this one represents superior batch. So this one represents superior batch, and this one represents regular batch. So this is the row for superior batch, and this is the row for regular batch. So in superior batch, they are using 8 pounds of beef, 2 pounds of pork, and 5 pounds of lamb. And this is the row for regular batch. So in the regular batch, they are using 4 pounds of beef, 8 pounds of pork, and 3 pounds of lamb. And they are producing total. We want to produce total 10 batches of superior and 20 batches of regular. Right. So now if we multiply these one, what we will get? So here, first of all, let us identify the dimension. So the first one, the dimension of this one. Dimension of this one is what? Here we have only one row. So here we have only, one. In this matrix, we have only one row and two columns. And in this matrix, we have 2 rows, 3 columns. So dimension of this one is 2 rows and 3 columns. So 2 rows and 3 columns. So that means this one matches with this one. So we can multiply. This one matches with this one. So that means number of column we have in the first matrix matches with the number of row in the second matrix. So we can multiply both. Matrix. So that means these will no longer be there. So if we multiply this one and this one, we will get 1 by 3 matrix. That means we will have 1 row, 3 column. So that means we will get a row vector actually. So 1 row, 3 columns, right? So here we can see we have 1 row and 3 column. So here we have 1 row. So here we can see we have only 1 row but 3 columns, right? So let us multiply. So we will first multiply this one with all the elements of the first column. So we will multiply this one with all the columns of this matrix. So first of all, we will multiply this row with first column. So 10 multiplied by 8 plus 20 multiplied by 4. So 10 multiplied by 8 plus 20 multiplied by 4. That means we get 160. So now we will multiply the first row with the second column. So first row with the second column. So 10 multiplied by 2 plus 20 multiplied by 8. So 20 multiplied, so that means 180. So now we will multiply first this row with the third column. So 10 multiplied by 5 plus 20 multiplied by 3. So 110. So that means we got 160, 180 and 110. So that means what we are getting here. So that means here, so we need to use total. This one represents. So this is the column for beef. This is the column for beef. This is the column for pork, and this is the column for lamb. I'm repeating again. This is the column for beef. This is the column for pork, and this is the column for lamb. So that means if we want to produce 10 batches of superior and 20 batches of regular meat spread, then in that case we will need total 160 pounds of beef, 180 pounds of pork, and 110 pounds of lamb. So that means we will need 160 pounds of beef, 180 pounds of pork, and 110 pounds of lamb to process all those batches. So that means to process 10 batches of superior and 20 batches of regular. So this is the interpretation. Now the second question. Suppose that per pound prices of beef, pork and lamb are this respectively. So that means suppose per pound prices of beef, that means beef price per pound is $250, pork price per pound is $2, and lamb price per pound is $3. So multiply the price vector and the meat matrix and interpret the result. So this is the price vector 2.5, 2 and 3. So this is the price vector. This one represents the price of beef, this one represents the price of pork, and this one represents the price of lamb. So question is asking us to multiply this is the price vector, and we need to multiply this one with meat matrix. So this is the column for beef, this is the column for pork, and this is the column for lamb. So that means what we are getting, cost. So let us multiply. So here dimension of these one is we have 1 row 3 column. So we have 1 row 3 column, and dimension of this one is we have 2 rows and 3 column. So multiplication, this means we can see that multiplication is not possible because this one is not matching. So here this one, what we have here, this is the price, meat price, this is the price for beef, this is the price of pork, this is the price of lamb. So that means these are the cost, and so this means these one in the row with what we are getting, in the row we are getting cost. That means the price or cost, that means price of meat or the cost of meat. And in the column we have type of meat. This one in the column, this is the beef, this is the pork, and this is the lamb. So in the column we have type of meat. In the first column we have beef, in the second column we have pork, in the third column we have lamb. So in the column we have type of meat, and in the row we have cost or price of meat. So here in the row we have what? Brand. This one represents superior. Sorry. This one represents superior brand, and this one represents regular brand. So this one, first the row in the row we have brand. In the row we have brand type. So that means in the row we have brand type. So in the row we have brand type, and in the column what we have, this one represents type of, this one represents beef, this one represents pork, this one represents lamb. So in the column we have meat type or type of meat. In the column we have type of meat. So as you see that we cannot multiply, the dimension is not matching. So let us switch this one. So let us switch this one. Let us transpose this one, right? So transpose means if the row become column and the column becomes row, if the rows become column and the columns become row, what we will have? So if you transpose the column, that means if you transpose the column, what we will have? Type of meat will become this one. This is the row. This one is representing the row, and this one is representing the column. So if you transpose this matrix, so that means this one brand will become the column and type of meat will become the row. So that means type of meat will become the row and brand will become the column. So type of meat will become the row and brand will become the column. So if you transpose means row will be row. If the rows become column and columns become row. So that means in that case this one will become the row and this one will become the column. So that means, so in the column we will have 825, in the second column we will have 483, right? So like that way. So now the dimension is matching. and also this one is also matching. This one is matching and dimension is also matching. Here this is we have 1 row and 3 columns, so 1 row and 3 column, and this one we have what? We have 3 rows 2 column, so we have 3 rows and 2 column. So these one and these one is matching, these one and these one is matching. So if you multiply, that means multiplication is now possible. So if you multiply, what we will have? We will have 1 by 2 matrix. That means we will have 1 row and 2 columns, which is actually not a matrix. This is a row vector. This is a row vector. So if you multiply, this one and this one is matching, so this one will no longer be there. So that means this one and this one is matching, this one will no longer be there. So we will have 1 by 2 matrix. So similarly, since this one and this one is matching, this one will no longer be there. So in the resulting matrix, we will have cost by brand. So in the resulting matrix, in the row we will have cost, that means the price of meat, and in the column we will have brand. So in the row we will have cost and in the column we will have brand. So let us multiply these now. So we will multiply first row with the first column. So 2.5 multiplied by 8 plus 2 multiplied by 2 plus 3 multiplied by 5. So this is 39. Again we will multiply the first row with the second column. So 2.5 multiplied by 4, 2 multiplied by 8, 3 multiplied by 3, that is 35. So what we are getting here? 39, 35. So that means, so in the row we are getting cost. So these are the cost, and in the column we have brand. So this one represents superior brand, this one represents cost of superior brand, this one represents cost of superior brand, and this one represents cost of regular brand. So this one represents 35 represents cost of regular brand, and 39 represents cost of superior brand. So this one, first one represents cost of superior brand and the second one represents cost of regular brand. So let us interpret. That means the total cost of a batch of superior is $39. That is, the total cost of a batch of superior is $39, and the total cost of a batch of regular is $35. Total cost of a batch of superior is $39 and the total cost of a regular batch is $35. So this way, if you have lots of brand of products in your company, if you produce lots of brand of products in your company, in that case you can use matrix to find cost of each product. Next question. Question number 23. 3 jewelry salespeople each regularly buy a certain quantity of watches, rings, necklaces, and earrings from their respective wholesale supplier and sell certain quantities of each item to a retailer. So we have 3 jewelry salespeople. Each of them regularly collect watch, rings, necklaces and earrings from supplier and sell certain quantities of each of those items to a retailer. Their respective buying and selling transactions during a particular month are given by the following vectors. So those jewelry salespeople, their buying and selling transactions during a particular month are given below. So B1 is the buying pattern of first sales guy, and sales S1 is the sales pattern of the first sales guy. So we have total 3 sales people. So B1 indicates the first sales buying pattern of the first sales people. S1 represents the selling pattern of first sales people. B2 represents the buying pattern of second salespeople, and S2 represents the selling pattern of second salespeople. B3 represents the buying pattern of third salespeople, and S3 represents the selling pattern of third salespeople. Right. So 10 represents the, so in a particular month, the first guy is buying 10 watches, 20 rings, 30 necklaces, and 40 earrings. In that month, he could sell 8 watches, 20 rings, 25 necklaces, and 35 earrings. So that means these one in the columns we have jewelry types. So in the column, this one represents watch, this one represents rings, this one represents necklace, and this one represents earrings. So in the columns we have necklaces, type of necklaces. In the columns we have type of necklaces, and in the row what we have quantity. In the row we have quantity of jewelries. Right. So where the first entry in each vector represents the number of watches, the second entry number of rings, the third entry number of necklaces, and the fourth entry number of set of earrings, that we have already discussed. The buying prices were $50 per watch, $50 per watch, $40 per earring, per ring, $25 per necklace, and $10 per set of earrings. So these are the price of each product. Price of watch is $50, price of ring is $40, price of necklace is $25, and price of a set of earring is $10. Whereas the selling prices were respectively these one. So selling price of watch is $75, selling price of ring is $55, selling price of necklaces is these $30, and selling price of each set of earrings is $15. So buying price and selling price is also there. So write the buying price as a column vector B. So write the buying price as the column vector B. So this is the buying price. This is the buying price. So 50, 50, 40, 25, 10. 50, 40, 25, 10. So this one represents the buying price of watch. This one represents buying price of ring. This one represents buying price of necklace. This one represents buying price of earring. And this one represents selling price of each of them. So the second question is asking, find the amount of revenue each salesperson expended in buying. So find the amount of revenue each salesperson expended in buying. That means we need to find out how much each of the salesperson spend it for buying those items, right? So buying those items. So this is the, so that means this is the buying matrix. 10, 20, 30, 40, 15, 25, 35, 45, 20, 10, 45, 35. This is the buying matrix of each of them. 10, 20, 30, 40, 15. So that means these are the buying matrix. 10. So this is the first row. This is the first row. So 10, 20, 30, 40. So you can see 10, 20, 30, 40. This is the, so as you can see here, this is the buying pattern of the first sales person. So this is the buying pattern. First row represents the buying pattern of the first sales guy. This one represents the buying pattern of the second sales guy. 15, 25, 35, 45. 15, 25, 35, 45. This is the second row represents the buying pattern of second sales guy. This one represents the buying pattern of third sales guy. So 20, 10, 45, 35. 20, 10, 45, 35. So this is the, these are the, so the in the row we have this one. The first row represents first sales guy. Second row represents second sales guy. Third row represents third sales guy. First column represents quantities of watches, second column represents quantities of rings, third column represents quantities of necklaces, the fourth column represents quantities of earrings. So that means in the column we have type of necklaces, in the row we have type of salesperson, right? That means in the row we have salesperson 1, 2, 3, right? So question is asking us to find out the total amount spended in buying. That means how much they have spent it in total, how much they have spent it in total to buy. So this is the buying. So this is the buying vector. 50 is the price of watch, 40 is the price of ring, 25 is the price of necklace, and 10 is the price of earrings. So this is the buying vector. So if you multiply these one, I'm repeating again, this one represents salesperson, first salesperson S1. This one represents second salesperson. This one represents buying pattern of third salesperson. So this one represents buying pattern of, so this row represents buying pattern of first salesperson. This one represents buying pattern of second salesperson. This one, third row, represents buying pattern of third salesperson. So what we have in the column, just a minute. So this one represents what? The first column. The first column represents watches. The second column represents what? Second column represents rings. The third column represents necklaces, and the fourth column represents earrings. So let me check if it is correct or not. Watches, rings, necklaces, earrings. Correct, fully correct. So the first column represents number of watches. Second column represents number of rings. Third column represents number of necklaces. Fourth column represents number of earrings. So the first sales guy is buying 10 watches every month, 20 rings every month, 30 necklaces every month, and 40 sets of earrings every month. So like that way information is given for each of the sales guy. Buying pattern of each of the sales guy is given. So this is the price of watch. This is the price of watch. This is the price of ring. So this is the price of ring. This is the price of necklaces. This is the price of a set of earring. This is the price of a set of earring. So if we multiply, what we will get? So what we will get? First of all, so here in the row, so let us identify the dimension first. Here we have one. So here we have 1, 2, 3. 3 rows are there. In the first matrix we have 3 rows are there. And how many columns are there? We have 1, 2, 3, 4. 4 columns are there. So and here in the second matrix we have 4 rows are there. And we have only 1 column is there. So 1 column is there. So that means we can multiply because this one is matching. So number of column that we have in the first matrix is matching with number of row of the second matrix. So we can multiply. So if you multiply, these will no longer be there. So we will have 3 by 1 matrix. So that means we will have 3 rows and 1 column. 3 rows and only 1 column. So multiplication is possible. Now let us check. So what we will get. So in the first matrix, the row, this is the first row, this is the second row, this is the third row. So sales people. So that means in the row we have sales people. In the row we have sales people. In the row we have sales people. So in the row we have sales people, and in the column we have type of necklaces. First column represents watch, second column represents ring, third column necklace, fourth column earrings. So that means in the column we have types of necklaces. So right. So now in the second matrix, in these matrix, what we have in the row we have types of necklaces. In the row we have types of necklaces. In the row we have types of necklaces, because first row we have watch, in the second row we have ring, in the third row necklace, in the fourth row we have earrings. So in the row we have types of necklaces. And in the column we have price or cost of each necklaces. So in the column we have cost of each necklaces. Cost of each. So in short we can just write cost. So in the column we have cost. So these two is matching with these one. These two is matching. So if we multiply the resulting matrix. The resulting matrix will have what? The resulting matrix will have salespeople by cost. So salespeople by cost. The resulting matrix will have salespeople by cost. So let us multiply. So first of all we will multiply first row with the first column. So what we will have? 10 multiplied by 50 plus 20 multiplied by 40 plus 30 multiplied by 25 plus 40 multiplied by 10. So equals to 2450. So similarly now we will move to second row. So we will multiply second row with first column. So 15 multiplied by 50 plus 25 multiplied by 40 plus 35 multiplied by 25 plus 45 multiplied by 10. So equals to this one. So like that way, if you multiply these two matrices, what we will get? We will get this one. So what this one is representing? So this one is actually representing these. So this one is actually representing this one. So that means in the row we have salespeople, and in the column we have cost, total cost. So in this row, so this one represents S1, so in the row we have salespeople. In the row we have salespeople. That means in the first row is S1, that is first sales guy. So first row is first sales guy. Second row is second sales guy. Third row is third sales guy. Third row is third sales guy. That means this is the total cost. That means total amount they are spending. They have spent it. This is the total amount they have spent it to buy those necklaces. This is the total amount they have spent it to buy those necklaces. So first sales guy, he has spent it $2,450 to buy those monthly necklaces. Second guy spent it $3,075 to buy those necklaces. So like that way we can get. So that means if we multiply this, what we will get? Salespeople expended these for $2,450, $3,075, $2,085, $2,875 respectively in buying. So they have spent this much amount of dollar to buy those necklaces monthly. Now the question is asking, third question, find the amount of revenue each salesperson collected in sales. That means how much they have sold. That means how much revenue they have earned by selling, right? So that means now we will include here same thing. Now we will include here sales price. Now we will include here sales price. So right, and sales vector. This one represents the sales matrix and this one represents the sales price, right? So this one represents the sales vector 8, 20, 25, 35. So 8, 20, 25, 35, and this is the sales vector for the second sales guy. So 15, 20, 30, 40. 15, 20, 30, 40. This is the sales vector for the third sales guy. 15, 20, 40, 35. 15, 10, 40, 35. So 15, 10, 40, 35. So this is the sales matrix. So this is the total quantities of necklaces they have sold, and this is the sales price, and this is the sales price. So this is the sales price 75, 55, 30, 15. So this is the sales price. So similarly like before, so here this is the dimension of this matrix. So the dimension of this matrix is what? The dimension of this matrix is, we have 3 rows and 4 columns. Again here we have 4 rows and 1 column. So 4 rows and 1 column. So that means this one is matching with each other. So that means number of rows, number of columns in the first matrix is matching with number of rows in the second matrix. So we can do the multiplication. So if you do the multiplication, what we will have, the resulting matrix will have 3 rows and 1 columns, right? So now let us find out what we will have in the answer. In the answer, so we need to understand how to interpret also. So what we will have in the answer, let us interpret that. So this one represents selling pattern of first sales guy. This one represents selling pattern of first sales guy. This one represents selling pattern of second sales guy. So this one represents selling pattern of second sales guy. This one represents selling pattern of third sales guy. So this one represents selling pattern of third sales guy. So first row represents selling pattern of first sales guy, second row represents selling pattern of second sales guy, third row represents selling pattern of third sales guy. So what we have, so this is the sales price. This is the sales price. So first one represents sales price of watch. Second one represents sales price of rings. Third one represents sales price of necklaces. Fourth price, sorry, not sales price. This is quantities of watches they are selling. So first column is representing quantities of watches they are selling per month. This one, second column represents quantities of rings they are selling per month. Third column represents quantities of necklaces they are selling per month. Fourth column represents quantities of earrings, that means sets of earrings they are selling per month. This is the sales price. This is the sales price of watches. So this one represents sales price of watch. This one represents sales price of ring. These one represents sales price of necklaces. So these one represents sales price of earrings. So this is the sales price. That means how much they are earning. So they are earning $75 from each watch. They are earning $55 from each ring. So that means, so if I write in the row we are having sales people. In the row we are having sales. So in the first matrix, in these matrix, in the rows we have sales people. So that means first row represents sales people 1, second row represents sales people 2, third row represents sales people 3. So that means the rows represents sales people. The rows represent sales people. And in the columns we have what? First column watches, second column rings, and like that. So in the columns we have types of necklaces. Right. Now the second matrix. In the second matrix, in the row we have watches, rings, necklaces, earrings. So that means in the row we have types of necklaces. In the second matrix we have, in the rows we have types of necklaces. And in the column we have sales price. This is the sales price of each of the watches. This is the sales price of each of the rings. This is the sales price of each of the necklaces. So in the column we have sales price, or that means revenue. So that means in the column we have revenue. Sales price, that means the revenue we earned. So in the column we can see this is the amount of revenue we are earning from each unit of watches. This is the amount of revenue that we are earning. Revenue means income. So this is the amount of income or revenue we are earning from each of the rings. So that means in the column we have revenue or sales price. So if we multiply these one and these one is matching, so that means these one and these one is matching. So that means if we multiply these one and these one is matching, these one and these one is matching. So that means if you multiply these one and these one will no longer be there. So what we will have in the resulting matrix, what we will have? We will have in the row we will have salespeople. In the row we will have salespeople, and in the column we will have revenue. In the column we will have revenue or total income. Revenue or total income. So let us multiply. Multiplication is very easy. So first row we will multiply the first row with the first column. That means 8 multiplied by 55 plus 20 multiplied by 30, 25 multiplied by 8 multiplied by 75, 20 multiplied by 55, 25 multiplied by 30, 35 multiplied by 15. So if we add all them, so we will get this one. So if you multiply, we will get this one. So this is the matrix or the column vector that we will get. So what this column vector is representing? So the column vector is representing this one. So that means this one is representing this one. So that means this is the, in the row we have type salespeople. So in the row we have, this is first row represents salespeople 1. First row represents salespeople 1. Second row represents salespeople 2. Second row represents salespeople 2. The third row represents salesperson 3. So third row represents salesperson 3. So that means, and in the column we have total revenue earned by each of the salesperson. So the first salesperson is earning first salesperson is making a total revenue of 2,975. Second salesperson is making a total revenue of is earning a total revenue of 3,725. Third salesperson is earning a total revenue of $3,400 per month. So that is the answer. So this way you should be able to interpret the results also. So salesperson realized, salespeople collected this much and this much respectively in selling. Right. Now the question is asking, find the amount of profit each salesperson realized. Assuming for simplicity that the unsold jewelry cannot be returned or otherwise sold. Right. So the question is asking how much each of the salesperson is making profit. So how much profit they have generated, right? So this is the total amount of revenue they are generating. This is the total amount of revenue they have generated. So this is the total amount of revenue they have generated, and this is the total amount they have spent it to buy those products. This is the total amount they have spent it to buy those products. So that means this is the total amount they have generated by selling those products. This is the total amount they have earned revenue. This is the total revenue they have earned, and this is the total amount they have spent it to buy those products. So if you deduct this one from this one, you will get the total profit. So this one minus this one, this one minus this one, this one minus this one. So the total profit made by each of the salespeople is this one. So this one, so salesperson 1 is making $525 profit per month. Salesperson 2 is making $650 per month. Salesperson 3 is making $525 profit per month. So salespeople realized 525, 650 and $525 of profit respectively. So that means this is the profit generated by, this is the profit made by salesperson 1, this is the profit made by salesperson 2, and this is the profit made by salesperson 3. So like that way, if you have huge number of seller and huge number of products producing, if you are producing huge number of products in your company, and if you have huge number of sellers or dealers, you can generate a matrix like that to find out the total profit made by each of the salespeople for the company. So this way you can deal with vast amount of data using matrix. So that's the end of application of matrix. So application of matrix, a matrix has very wide application. So in this course I have shown you only a few example or only a few application of matrix. So that's the end of application of matrix. So that's the end of matrix chapter.